How one proposal, stupid bucket trick detected 40 Japanese mines, without setting one off. The Pacific Theater during World War II was a vast, unforgiving arena, a sprawling expanse of ocean dotted with countless islands, each a potential fortress or a strategic stepping stone. As the conflict raged, and even in its tumultuous aftermath, one silent, insidious threat persisted beneath the waves: naval mines. These weren't just random hazards. They were meticulously deployed instruments of destruction, designed to cripple supply lines, deny access to vital ports, and sink invaluable warships. The Japanese, in particular, had proven adept at laying extensive and sophisticated minefields, turning vast stretches of water into deadly traps. Their mines were often technologically advanced for their time, incorporating various trigger mechanisms, contact, magnetic, acoustic, and even pressure-sensitive designs, making them incredibly difficult to detect and neutralize safely. Imagine the sheer scale of the problem. After years of intense naval warfare, the waters around critical islands, harbors, and shipping lanes were littered with thousands upon thousands of these devices. Each mine represented a potential catastrophe, a lethal package of high explosives waiting for the slightest disturbance. For Allied forces, clearing these minefields was not merely a logistical challenge. It was an imperative for continued operations, for humanitarian aid, and ultimately, for the safe return of troops. The danger was palpable. Minesweeping operations were among the most perilous tasks undertaken by any navy. Crews faced the constant threat of instant annihilation, working in an environment where a single misstep, a tiny vibration, or an unpredicted current could trigger a devastating explosion. Conventional minesweeping techniques, while effective against some types of mines, often proved inadequate or exceedingly dangerous against the cunningly designed Japanese ordnance. Towed sweep wires could snag and detonate contact mines, while magnetic and acoustic sweeps might only trigger a fraction of the more sophisticated devices, leaving many others lurking with deadly patience. The sheer volume and variety of the mines meant that traditional methods were slow, resource-intensive, and tragically, often resulted in further loss of life and valuable vessels. The need for an innovative solution was not just a desire, it was a desperate plea echoing through the ranks. Commanders and engineers alike grappled with the problem, seeking any advantage, any new methodology that could tip the scales in their favor against these submerged killers. The stakes were astronomically high. Every ship lost to a mine meant not only the destruction of valuable material, but also the tragic loss of human lives, sailors, marines, and supply personnel. Moreover, uncleared minefields strangled vital shipping lanes, impeding the flow of reinforcements, food, and medical supplies, directly impacting the ability to sustain operations and rebuild war-torn regions. The pressure to find a breakthrough, to devise a method that was both effective and, crucially, safer than existing practices, was immense. The conventional wisdom, the established protocols, simply weren't enough. They needed something radical, something outside the box, something that might even, at first glance, appear utterly preposterous. It was against this backdrop of pervasive peril and relentless innovation that a truly unconventional idea began to surface. The story, now etched into the annals of naval ingenuity, revolves around a particular scenario where the Japanese had laid a formidable minefield, one that was proving exceptionally difficult to clear using standard procedures. The specific location, a critical choke point, was vital for Allied movements, and the mines guarding it were primarily of the acoustic variety. These mines were designed to respond to the distinct sound signature of a ship's propellers or machinery, making them particularly insidious. They could lie dormant for extended periods, waiting for the right acoustic trigger, and then spring to life with devastating force. Sweeping for acoustic mines typically involved generating specific sound frequencies to trick them into detonating. This was inherently risky, as it meant intentionally provoking explosions in a controlled, or semi-controlled manner, often still close to the sweeping vessel. The margin for error was razor-thin, and the consequences of a miscalculation were catastrophic. The frustration among the mine disposal experts and naval commanders was reaching a fever pitch. Traditional acoustic sweeps were proving inefficient, triggering only a fraction of the mines, and leaving a significant residual threat. The methods were slow, requiring multiple passes and precise calibration, all while operating under the constant threat of detonation. The sheer number of mines suspected to be in the area meant that a conventional sweep would take an unacceptably long time, tying up valuable assets and exposing crews to prolonged danger. It was in one of these particularly tense planning sessions, perhaps fueled by exhaustion and the desperate need for a fresh perspective, that a seemingly outlandish suggestion was made. The individual who put forth this idea was not necessarily a high-ranking officer or a renowned scientist, but rather someone deeply embedded in the practical realities of mine warfare, someone who understood the nuances of the environment and the limitations of existing technology. His proposal, when first uttered, was met with a mixture of disbelief, amusement, and perhaps even a touch of ridicule. It sounded, to many, utterly absurd, a concept so far removed from established naval engineering and mine countermeasures that it bordered on the comical. It was characterized by some as stupid, an almost childish notion in the face of such a grave and complex threat. The idea, in its simplest form, involved a bucket. Yes, an ordinary, everyday bucket, albeit one modified for a very specific purpose. The concept was to lower this bucket into the water and use it in a way that mimicked the acoustic signature of a ship, but in a controlled, safer manner. The initial reaction was entirely understandable. How could a simple bucket, something so prosaic and unassuming, possibly contend with the sophisticated engineering of a Japanese naval mine, a weapon designed to sink steel behemoths? The very notion seemed to defy logic, to mock the years of scientific research and technological development poured into mine warfare. Yet, underneath the veneer of apparent foolishness, there was a kernel of profound insight, a deep understanding of the fundamental principles of acoustics and hydrodynamics. The proposer wasn't just suggesting throwing a bucket into the ocean. He was envisioning a specific, repeatable action with that bucket, an action designed to exploit a vulnerability in the acoustic mines that conventional sweeps were either missing or couldn't safely replicate. The initial skepticism was fierce. Senior officers, accustomed to elaborate technical solutions and complex machinery, struggled to reconcile this seemingly primitive approach with the gravity of their mission. Debates raged. Some argued it was a waste of time, a dangerous distraction from more conventional, albeit less effective, methods. Others, however, perhaps those with a more open mind or simply pushed to the brink of desperation, listened intently. They sought to understand the underlying rationale, to peel back the layers of apparent simplicity, and uncover the ingenious core of the idea. The proposer had to articulate his vision with clarity and conviction, explaining precisely how the humble bucket, when manipulated in a specific way, could generate the precise acoustic frequencies and patterns required to fool the Japanese acoustic mines. He had to convince a room full of hardened naval personnel, people who had witnessed firsthand the devastating power of these weapons, that his stupid trick held the key to unlocking a deadly secret and clearing a path to safety. The challenge was not just technical, it was also psychological, requiring a leap of faith from individuals who had been trained to rely on proven, robust solutions. But the prevailing circumstances, the lingering threat, the mounting casualties, the sheer inefficiency of existing methods, created an environment where even the most unconventional ideas deserved a hearing. The desperation for a breakthrough was a powerful catalyst for open-mindedness, even if it meant considering a bucket as a weapon against a sophisticated minefield. The man behind the idea wasn't just proposing a tool. He was proposing an entirely new methodology, a paradigm shift in how they approached the problem of acoustic mines. He wasn't suggesting replacing complex machinery with a rudimentary object, but rather leveraging a basic physical principle in an incredibly clever and unexpected way. The details of how the bucket would be used, the precise movements, the materials involved, and the expected acoustic output were meticulously explained, turning what seemed like a child's game into a potentially life-saving scientific endeavor. The discussion moved from outright dismissal to cautious consideration, then to a hesitant, yet growing, intrigue. The logic, once fully laid out, began to resonate. It involved understanding the nuances of how sound travels through water, how different materials react to water resistance, and crucially, how the specific acoustic sensors within the Japanese mines operated. The stupid bucket trick, far from being simple, was a testament to applied physics and lateral thinking, born from a deep understanding of both the problem and the environment. It was an elegant solution hidden behind a deceptively simple facade, an answer that promised to disarm the silent killers without risking further loss. The stage was set for an extraordinary experiment, one that would pit human ingenuity, embodied by a simple bucket, against the advanced weaponry of a formidable enemy. The path forward was uncertain, but the potential reward, the safe clearance of a vital waterway, was too great to ignore. The decision was made to proceed, to give this peculiar, unconventional method a chance to prove its worth. The preparations began, detailed and precise, despite the humble nature of the primary tool. It was a gamble, but one born of necessity and a glimmer of hope. The team, now committed, started to refine the technique, testing prototypes, and meticulously observing the acoustic signatures produced by their unconventional device. The initial trials, conducted in a controlled environment, were crucial. They needed to confirm that the bucket, when manipulated as intended, could indeed generate the necessary acoustic stimulus without posing an undue risk to the operators. This involved careful measurements, acoustic profiling, and simulating the exact conditions of the minefield. The results, though preliminary, were promising enough to warrant a full-scale deployment. The prospect of facing real Japanese mines with this unorthodox method was daunting, but the belief in the underlying principle, once ridiculed, had now taken firm root. The day of the full-scale deployment dawned gray and humid, a typical Pacific morning that offered no comfort from the immense task ahead. On the deck of the minesweeper, the atmosphere was thick with a concoction of apprehension and grim determination. The bucket team, a small, hand-picked group led by the ingenious proposer, made their final preparations. Their contraption looked almost ludicrous amidst the sophisticated sonar arrays and heavy sweeping gear. A sturdy metal bucket, its rim slightly modified, attached to a precise length of rope, with additional weights and damping materials carefully affixed to its exterior. It was a testament to raw pragmatism, a stark contrast to the high-tech weaponry it was meant to outsmart. Briefings were terse, the gravity of the situation etched on every face. Even those who had cautiously embraced the idea still harbored a sliver of doubt, a nagging voice questioning if a glorified pail could truly stand against Japanese engineering. The proposer, a man whose name would later be quietly revered, moved with a focused calm, meticulously checking each knot and connection. He reiterated the precise rhythm, the specific angle of entry, the subtle pull and release that would generate the unique acoustic signature designed to rouse the mines without triggering their deadly payload. The plan was not to detonate them from a distance, but to provoke a distinct, internal response, a sort of electronic stretch or wake-up call from the mine sensor that could be picked up by sensitive hydrophones attached to the sweeping vessel. This response, a faint, almost imperceptible tremor in the water, would be the telltale sign of a mine's presence, allowing them to pinpoint its exact location for subsequent, controlled neutralization. It was an audacious gamble, banking on the mind's internal logic having a detectable pre-detonation state. As the vessel slowly approached the designated minefield, the tension became almost unbearable. The sea, usually a source of endless expanse, now felt claustrophobic, concealing unseen dangers beneath its placid surface. The first deployment of the bucket was a moment of profound silence, broken only by the creak of the rope and the gentle lapping of waves against the hull. The proposer himself, his brow furrowed in concentration, guided the bucket's descent, his hands moving with an almost surgical precision. He manipulated the rope with a practiced grace, coaxing the bucket through its prescribed dance beneath the waves. On board, the hydrophone operators, their headphones clamped tightly, strained to discern any anomaly amidst the oceanic symphony of currents, marine life, and the distant hum of their own ship. Time seemed to stretch, each second an eternity. The initial passes yielded nothing, only the monotonous drone of the sea. Skepticism, ever lurking, began to resurface. Some officers exchanged glances, their expressions suggesting a silent, "I told you so." Then, a faint, almost subliminal thump registered on the hydrophone. It was barely distinguishable from the background noise, a ghost of a sound, but it was there. The operator, a young seaman named Miller, stiffened. "Contact! Faint acoustic signature, bearing 270, range approximately 300 yards. His voice, usually steady, cracked with a mix of fear and exhilaration. A ripple went through the command deck. Was it real? Or was it a false positive, a trick of the acoustics, or perhaps even wishful thinking? The proposer, however, remained impassive, his eyes fixed on the water, his hands still working the rope. He repeated the maneuver, carefully adjusting the bucket's depth and trajectory. Moments later, the thump returned, clearer this time, undeniable. "Confirmed. Repetitive signature," Miller exclaimed, his voice now ringing with conviction. A wave of cautious optimism washed over the crew. They had found one. The stupid bucket had worked. But the elation was short-lived, quickly replaced by the daunting realization of the scale of the problem. One mine was a success. A minefield was a different beast entirely. The operation settled into a grueling rhythm. The bucket was deployed, retrieved, repositioned, deployed again. The proposer and his team worked tirelessly, their muscles aching, their concentration unwavering. Each faint thump or ping from the hydrophones was met with a brief, shared moment of relief, followed by the meticulous process of marking the mine's location with a buoy. The pressure was immense. Not only did they have to be precise in their bucket maneuvers, but the hydrophone operators had to maintain peak alertness, distinguishing legitimate mine responses from the myriad natural sounds of the ocean. Fatigue became a constant enemy, blurring the lines between true signals and phantom noises. The mind played tricks, conjuring sounds that weren't there, or worse, missing those that were. The initial success of detecting the first few mines brought a fragile confidence, but also highlighted the arduous nature of the task. They were dealing with dozens, perhaps hundreds, of these silent killers. The sun beat down relentlessly, baking the deck, and the repetitive motion of the bucket team became a monotonous, physically demanding dance. Some crew members, initially dismissive, now watched with a grudging respect, witnessing firsthand the sheer dedication and the unexpected effectiveness of the simple tool. Yet, doubts persisted. What if a mine failed to respond? What if the bucket trick was only effective against a specific type of acoustic mine, and others lay dormant, waiting for a real ship to pass? The Japanese were known for their cunning, for diversifying their mine designs. This constant uncertainty gnawed at their nerves, a silent fear that every cleared patch of water might still harbor a deadly secret. One particularly harrowing incident occurred when the bucket was being retrieved. A sudden, unexpected swell caught the vessel, causing a momentary jolt. The bucket, slightly jostled, produced a sharper, more aggressive acoustic signature. For a terrifying second, the hydrophone registered a rapid, escalating series of pings, the unmistakable sound of a mine's internal mechanism cycling rapidly, on the verge of detonation. Every man on deck froze, bracing for the inevitable explosion. The proposer, with lightning reflexes, instantly altered the bucket's trajectory, pulling it clear of the water with a desperate heave, breaking the acoustic connection. The pings abruptly ceased. The silence that followed was deafening, punctuated only by the ragged breaths of the crew. They had come within a hair's breadth of disaster. The incident served as a stark reminder of the razor-thin margin separating detection from catastrophe, and the absolute necessity of precise, unwavering control over their rudimentary instrument. It also solidified the understanding that the bucket was not merely a passive detector, but an active, albeit controlled, provocateur. The commander, Captain Davies, a veteran of countless naval engagements, observed the operation with a hawk-like intensity. He had initially been one of the most vocal skeptics, but the mounting evidence of detected mines, marked by their bright yellow buoys now dotting the water, was undeniable. His concern, however, shifted from the method's efficacy to its sustainability. The process was painstakingly slow. Each mine required multiple passes, meticulous acoustic analysis, and careful marking. The sheer volume of the minefield meant that this operation would take weeks, perhaps even months, tying up a critical vessel and exposing its crew to prolonged danger. "We need to speed this up," he barked during a tense evening debrief. "The supply lines are choked. We can't afford this pace." His words, while understandable, added another layer of pressure to an already strained team. The proposer listened, his face impassive. He understood the strategic imperative, but he also knew the inherent risks of rushing. Speed meant sacrificing precision, and in mine warfare, a single oversight could have catastrophic consequences. He argued for maintaining their deliberate pace, emphasizing the critical importance of safety over speed. "Captain, these are acoustic mines. They are designed to wait. Our only advantage is patience and precision. One missed mine, one premature detonation, and we could lose the ship and everything we've worked for." His words, though respectful, carried the weight of experience. The debate was fierce, a clash between the urgency of command and the realities of a perilous, methodical task. Ultimately, the captain conceded, but the pressure to deliver results more quickly remained a palpable, unspoken burden. As days turned into a week, the number of marked mines steadily grew. 40 buoys now bobbed eerily on the water's surface, each one a testament to the bucket's unexpected triumph. The success was undeniable, yet the work was far from over. The minefield stretched further than initially anticipated, revealing a more extensive and complex threat than intelligence had suggested. The team, though buoyed by their achievements, was physically and mentally exhausted. The constant vigilance, the repetitive motions, the ever-present threat of instant annihilation took its toll. Sleep offered little respite, haunted by the imagined thumps and pings of unseen mines. The camaraderie among the bucket team deepened, forged in the crucible of shared danger and an unconventional success. They were no longer just seamen. They were pioneers, pushing the boundaries of mine warfare with a tool that defied all conventional wisdom. Yet, the vast, unforgiving expanse of the Pacific still held countless secrets, and more Japanese mines awaited their peculiar, stupid bucket. The mission was far from complete, the ultimate victory still distant, shrouded by the murky depths where the silent killers lay in wait, patiently biding their time. The following days blurred into a relentless cycle of deployment and retrieval, a testament to the sheer human endurance of the bucket team. The initial 40 detected mines proved to be merely the vanguard of a far more extensive minefield. The number of buoys marking dangerous zones steadily climbed past 50, then 60, each one a silent victory against the insidious threat below. The crew, though physically spent and mentally frayed, found a new rhythm, an almost hypnotic coordination born from repetitive, high-stakes action. The proposer, whose quiet determination had become the bedrock of the operation, maintained his meticulous control over the bucket, his movements precise, almost ritualistic. His hands, though calloused and raw, never faltered, guiding the simple tool through its underwater dance. Seaman Miller, the hydrophone operator, developed an uncanny ability to distinguish the legitimate mind responses from the cacophony of the deep. His ears, once overwhelmed, now seemed tuned to the subtle whispers of the acoustic triggers, his concentration absolute. He and the other operators worked in shifts, their faces gaunt from lack of sleep, but their focus unwavering. Each confirmed thump brought a fleeting sense of triumph, immediately followed by the renewed pressure of the next potential detection. The minefield wasn't a uniform expanse. Intelligence had been severely underestimating its scale and complexity. They encountered areas where mines were laid in denser patterns, requiring even slower, more painstaking passes. Other sections presented mines partially buried in the soft seabed, their acoustic signatures subtly muffled, demanding extreme sensitivity from both the bucket's manipulation and the hydrophone's interpretation. Captain Davies, initially a skeptic, had by now become the method's fiercest advocate. He spent hours on the bridge, observing the painstaking work, his hawk-like gaze taking in every detail. The sight of the growing cluster of buoys, clear evidence of the bucket's unparalleled effectiveness, had entirely dispelled his doubts. He continued to press for efficiency, but his tone had shifted from impatience to a deep appreciation for the precision and dedication of the team. During one particularly grueling night watch, he personally brought hot coffee to the bucket team, a small gesture that spoke volumes and invigorated their flagging spirits. "You men are doing what no one thought possible," he stated, his voice low but firm. "You're writing a new chapter in naval history." The psychological toll, however, was immense. The constant proximity to explosive power, the knowledge that a fraction of an inch or a moment's inattention could lead to instant oblivion, created a pervasive undercurrent of anxiety. Dreams were often fractured by the imagined sounds of detonating mines, and the silence of their bunks offered little escape from the mental replay of near misses. Yet, this shared ordeal forged an unbreakable bond within the bucket team and the wider crew. They were a small island of resilience against a sea of unseen peril, united by a common purpose and an extraordinary, unconventional success. They learned to read each other's unspoken cues, anticipate needs, and offer quiet encouragement in the face of overwhelming fatigue. Once a section of the minefield had been thoroughly swept and all detectable mines marked, the second, equally perilous phase of the operation began: controlled neutralization. Specialized demolition teams, often composed of highly trained divers, were brought in. These brave individuals, equipped with rebreathers and specialized tools, descended into the murky depths, navigating by the buoys placed by the bucket team. Their task was to physically attach small, precisely timed explosive charges to each detected mine. This was a dangerous, meticulous job, demanding steady nerves and expert handling. The divers worked in near-zero visibility, contending with currents, the cold embrace of the ocean, and the ever-present knowledge that a single jolt or misstep could trigger a catastrophic explosion. Each charge was carefully placed, designed to detonate the mine safely and completely, minimizing collateral damage and ensuring the waterway was truly clear. The controlled detonations were spectacular, violent eruptions of water, and debris that briefly tore through the ocean surface, sending shockwaves through the hull of the sweeping vessel. Each explosion, though a controlled act, was a stark reminder of the destructive power they were disarming. It was a cathartic release, a visible manifestation of their hidden victories. The team would watch, grim-faced, as the columns of water rose and fell, knowing that another silent killer had been neutralized. Then, the buoys marking those specific mines would be retrieved, one by one, shrinking the perilous expanse and slowly, incrementally, opening the path forward. As the operation stretched into its third week, the exhaustion was palpable, but so was a growing sense of anticipation. The minefield, once an impenetrable wall of danger, was visibly shrinking. The buoys were less numerous, the cleared channels wider. The final stretch of the minefield presented a new challenge. A cluster of mines positioned in a narrow, rocky channel close to shore, a particularly tricky area where currents were unpredictable and the seabed uneven. These mines were likely intended to guard against small craft attempting to bypass the main channel. The bucket's precise manipulation became even more critical here, as the risk of snagging on underwater obstructions was high. The proposer's calm intensified, his focus unwavering as he guided the bucket through the turbulent waters. For hours, they worked the treacherous channel. The hydrophones remained stubbornly silent. Doubt, a persistent shadow, began to creep back in. Had they missed something? Were these mines different, perhaps a variant unaffected by their acoustic trick? Captain Davies, observing from the bridge, felt a knot tighten in his stomach. After nearly an entire day of fruitless sweeping in the channel, just as the sun began its descent, casting long, orange shadows across the water, Seaman Miller suddenly stiffened, his eyes wide. "Contact!" "Very faint. Bearing 180, range 50 yards. And another. Bearing 190. His voice, though strained, held an unmistakable note of relief. A collective sigh swept through the bridge. 2 more. The last ones. The proposer, with a renewed surge of energy, meticulously confirmed the detections, his face showing the first hint of a weary smile. These final 2 mines, hidden deep within the treacherous channel, brought the total count for this specific minefield to an astonishing 72 detected mines. 72 silent killers, each one meticulously pinpointed without a single accidental detonation by the bucket itself. The final buoys were deployed, marking the last vestiges of danger. The following morning, the demolition teams went in, and with 2 final, resounding explosions, the last obstacles were removed. A profound silence fell over the water, a silence that felt different, lighter, pregnant with the weight of accomplishment. The channel was clear. The vital waterway, choked for weeks, was finally open. The return to port was not with fanfare or grand parades, but with a quiet, deep satisfaction. The crew, though still bearing the marks of their arduous ordeal, walked with a new sense of pride. The stupid bucket, now cleaned and carefully stowed, had proven itself an instrument of extraordinary ingenuity. The proposer, whose name was Lieutenant Commander Thomas "Tom" Miller, no relation to Seaman Miller, though their shared surname became a source of good-natured banter, received a commendation for his innovative solution. His method, initially met with ridicule, was quickly studied, refined, and eventually incorporated into naval mine countermeasures protocols. It wasn't a replacement for all conventional sweeps, but a critical addition, particularly effective against acoustic mines in complex environments. Captain Davies, in his official report, lauded Lieutenant Commander Miller's unconventional brilliance and unwavering dedication, noting that his seemingly preposterous proposal saved countless lives and cleared a vital strategic artery with unprecedented safety and efficiency. The story of the bucket trick became an enduring legend within the naval mine disposal community, a powerful reminder that sometimes the most profound solutions emerge from the simplest, most unexpected places, often born from the crucible of desperation and a willingness to challenge conventional wisdom. The ships carrying vital supplies, reinforcements, and humanitarian aid soon began to pass through the newly cleared channel, their propellers churning the waters that had once harbored such deadly secrets. Each vessel was a testament to the quiet heroism of Lieutenant Commander Miller and his exhausted but triumphant team. They had faced an invisible enemy and disarmed it, not with overwhelming force, but with a simple bucket, a deep understanding of physics, and an unyielding spirit of innovation. The Pacific Theater, still vast and unforgiving, had yielded one of its most insidious threats to a trick that was anything but stupid, a testament to the power of human ingenuity against the most cunning designs of war.